According to a recent survey of 1,379 voters, 57% feel that the president is doing an acceptable job. Construct a 95% confidence interval for the population proportion of voters who feel the president is doing an acceptable job. Okay, so we have a sample proportion here. We know 57% of the voters we surveyed feel the president is doing an acceptable job. So that's our p-hat. 57% is 0.57. Okay? We want to construct a 95% confidence interval for how the population proportion is. Where does that population proportion live? Okay? So next, let's calculate alpha. Remember, alpha is the probability that the population proportion is not in our confidence interval. So alpha is always equal to 1 minus the confidence level. 100% minus the probability that the population proportion is in our confidence interval is equal to the probability that the population proportion is not in our confidence interval. Okay, so let's just plug in. The problem tells us our confidence interval, or our confidence level. We want to construct a 95% confidence interval. So 95% is our confidence level. And so 0.95, which means my alpha is equal to 1 minus 0.95, or 0.05. Okay? Now we want to find z alpha over 2. The idea here being we need the z-score if we look at the standard normal distribution, we want our confidence interval here to represent the central 95% of our distribution. Okay? And so alpha represents the area left over. This is alpha over 2 in each tail, half of that in each tail. We want the z-score with area alpha over 2 to the right of it. So in order to do that, since we know a probability and we want to find the z-value, we use the q-norm function, we plug in the probability. Now the probability we have here, this alpha over 2, that's in the upper tail. Remember, this p is expecting a probability in the lower tail, so to deal with that, we do 1 minus the probability in the upper tail. 1 minus alpha over 2. That's going to give us our z-score. So our z alpha over 2 is 1.959964. So now let's take that and find the margin of error. Call the margin of error is that z alpha over 2 we just calculated multiplied by the standard error of the sampling distribution, which is going to be p hat times 1 minus p hat over the sample size n. Okay? Why don't I go ahead and start by calculating that standard error. So our standard error is going to be square root of, and I'm going to take my p hat, my sample proportion, which we found here, 0.57. So 0.57 times 1 minus 0.57 divided by the sample size. The sample includes 1,379 voters. So 1,379. And so that's my standard error. I'm going to use that to calculate my margin of error. So all I have to do now is take that standard error and multiply it by my z value that I calculated. Okay, my z alpha over 2. So that means my margin of error is just the z value that I found times the standard error. It's 0.0261299. That's my margin of error. Okay, we're almost done. To find the actual bounds for our confidence interval, we want to take our point estimate, p hat, and subtract our margin of error. That'll give me my lower bound. And then take my point estimate, p hat, and add my margin of error. That'll give me my upper bound. Okay? So my lower bound is my p hat, my 0.57, minus my margin of error, e. So that's a smaller number. Okay? And then the larger bound, the upper bound for my confidence interval is my point estimate plus my margin of error. Which means we are 95% confident, based on our sample data, that the true proportion of voters who feel the president is doing an acceptable job is between 0.5438701 and 0.5961299. So about between 54 and 60%. That's where we think that the true population proportion is. Okay? So this allows us to estimate that population proportion while still capturing that sense of uncertainty we get because we're not gathering data for the whole population. We're just gathering it for 1,379 voters from that population.